Today I'm just going to build on what we learned in the last video on effective nuclear charge and talk about how that influenced trends across the periodic table. So the first trend is atomic size or atomic radius, and the size of an atom is basically the distance, or the radius is the distance between the nucleus and the valence electrons. So those are the outer electrons for the atom. Now, as we go down the periodic table, we are adding energy levels each time. So the first one would only have, the first energy level would be one shell, and then as we go down the next row, now we have the second energy level, which is a little bit bigger, and then the next row we have the third energy level, and so on. So as you go down the periodic table, as you probably would expect, we're adding shells of electrons, and so the atomic radius is going to get larger. Okay, as we go across the periodic table, it's not as intuitive what happens. So in that case, we're in the same energy level the whole way across that row. And then what does change, other than we're adding electrons to that same shell, but the other thing that changes is we're also adding protons to the nucleus. So our effective nuclear charge is going up as we go across the periodic table, which you learned about in the last video. And as our effective nuclear charge goes up, the electrons are going to be pulled in tighter toward the nucleus because that charge is bigger. So as we go across the periodic table, the Z effective goes up, right, which is going to pull the electrons in a little bit tighter. So we're going to get smaller as we go across the periodic table. The next trend we're going to talk about is ionization energy, and ionization energy is the energy that's needed to remove one electron from an atom when it's in the gaseous state, right? So removing one electron from the atom, the tighter the electron is held, the harder it's going to be to remove the electron. So as we go down the periodic table, as I just said on the previous slide, the atoms are going to get bigger. So the electrons are going to get further from the nucleus, which means it's going to be easier to remove those electrons. So as we go down the periodic table, it's going to get easier to remove the electrons, so the ionization energy is going to get lower. And as we go across this way, remember our effective nuclear charge is going up, and so that means the electrons are going to be held more tightly. So as we go across, the ionization energy is going to go up because it's going to get harder to remove electrons. The last one that I'm going to discuss is electronegativity, and this one is not in this chapter in your textbook. It's actually in chapter 10 because we haven't yet covered bonding, but I'm assuming at this point that you can understand what a bond is even though we haven't discussed it in detail. So electronegativity is the ability of an atom to attract electrons toward itself when it's in a chemical bond, all right? So this is going to follow a very similar trend to ionization energy. So as we go down, the atoms are going to get bigger, which means that we have more shells of electrons, and so that means that it's going to be harder for that nucleus to pull electrons toward it, so the electronegativity is going to go down. As we go across, our Z effective is going to get bigger, which means that those electrons can be pulled toward the nucleus more easily, and so our electronegativity is going to increase as we go across the periodic table from left to right. All right, so just to summarize what we just covered, and it's important that not only do you know what the trends are, so what this chart looks like, but also that you can explain why. So based on what I just explained in the last few slides about energy levels changing as you go down and about the effective nuclear charge changing as you go across, those are the explanations I want to hear on the test or in class as to why the trends are what they are, not just what they are. All right, so first, atomic radius, as you move from left to right, the atoms get smaller, and as you move down the periodic table, they get bigger. All right, ionization energy, as you move from left to right on the periodic table, the ionization energy goes up. As you move down, the ionization energy is going to go down because it's going to get easier to remove electrons. And then finally, for electronegativity, as we move across the periodic table, they get more electronegative. And as we move down a column on the periodic table, they get less electronegative. All right, so this summarizes the periodic trends. We're going to do some stuff with these in class as well, and you can find all of this information in your textbook as well.